sketching polynomials. So sketching polynomials. So there's a couple key sort of attributes that polynomials have which will help us sketch them more easily. So the first is degree and end behavior. And the second is multiplicity and zeros. So let me go ahead and explain these. So the first is degree and end behavior. So the degree of your polynomial is going to greatly influence how the function behaves as it goes to negative infinity and as it goes to positive infinity. So if you have an even exponent, so if your leading term of your polynomial is x to some even number, so even, then the graph of your function is going to end up looking like a u. So for example, x squared, where 2 is even, looks like this somewhat, right? And if you tack a negative sign to it, it'll just flip vertically like this. So the key thing to notice here is that you end on the same side of the x-axis as you started. So the same side of the x-axis as you started. Even if you have more terms like x squared plus x plus 1 or something, and you do some funky stuff in the middle, you're still going to end up like on the same sort of side of the x-axis, or if you're negative, then like this, right? You're still going to end up on the same side of the x-axis. Now the other case we have is x to the odd numbers. So whenever our leading term of our polynomial is, some coefficient times x to some odd term, for example, like x cubed, then our graph is going to end up looking like this, right? It's going to start on one side of the x-axis and then make its way to the other side. And if we put a negative sign, it's going to go down like that, but they still end up on opposite sides of the x-axis. Again, you can have x cubed minus 2x squared plus x. It doesn't matter. Your function can do all sorts of crazy stuff in the middle, but the end behavior is going to end up on opposite sides, or like this, right? It's always going to be on opposite sides. So that's degree and end behavior. Now the second attribute we're talking about is multiplicity. So oftentimes when we're given polynomials, they'll be factored. So for example, let's say we have x minus 1 squared times x plus 1. So what this means is it can tell us two things. One, we know this is going to be a cubic function because if we sum these exponents, in this case there's a 2 and a 1 here, then 2 plus 1 will give me 3, which means this whole thing, when I multiply it out, will end up being a cubic function. And if there's no negative sign in front, then we know that this is going to be a positive cubic function, which means it's going to follow the blue function's end behavior, this end behavior. And the other thing we can notice is that based on the exponent of each individual factor, we can tell what's going to happen to the function at that 0. So we know that each factor determines a 0 for our function because then the opposite number to whatever number is in our factor is going to be the 0. So in this case, we have a negative 1, so our 0 is going to occur at 1. If in this case we have positive 1, so our another 0 is going to occur at negative 1. So because in this factor that has a 0 at 1, we have an even exponent of 2. At x equals 1, so at x equals 1, our polynomial is going to touch the x-axis, right? It's going to touch it. In this case, at x equals negative 1, for that 0, we have an odd multiplicity there, odd exponent. So at x equals negative 1, our function is going to cross the x-axis. So even multiplicity means touching, and odd multiplicity means crossing. And even degree means U-shape, and odd degree means opposite end behavior. So let's take a look at a few examples to figure out how we can actually apply this to sketching polynomials. So our first example will be f of x equals x cubed minus 2x squared minus 24x. So the first thing we want to do whenever we see a polynomial that's not already factored is we want to factor it. So we set this equal to 0 equals 0, and then once we factor it, we can actually determine what the zeros of our function are. So we notice that each of the terms in this polynomial have an x in them. So that means we can factor out an x. So if I take out an x from each of these terms, I'm going to get x times x squared minus 2x minus 24. And then I also noticed that when I factor that, this cubic or this quadratic is right here, and I know that that can be factored. So when I'm factoring quadratics, I'm looking for two numbers that multiply up to this n term, negative 24, and add up to the middle term, negative 2. So two numbers that multiply up to negative 24 but add up to negative 2 are negative 6 and positive 4. So I'm going to have x times x minus 6 times x plus 4. And here our function is fully factored. So again, now what we're going to do is determine our zeros. So for each factor, we're going to take the opposite number of whatever's in the factor. So here there's no number, so it's just going to be 0. In this factor, we have x minus 6, so our 0 is going to happen at 6. And here we have x plus 4, so our 0 is going to happen at negative 4. So if we draw a graph here for a second, so I'm going to draw a graph like so, and I label it, I'm going to have zeros at negative 4, which will be somewhere over here. So there's going to be a 0 there, at 0, and at positive 6, which would be like over here somewhere. And we also notice from this function that it's a positive cubic because our leading term is positive and cubic. So what that means is it's going to follow this end behavior that I showed you up here of the blue function, this blue function right here. So it's going to start on the negative side of the x-axis and end up on the positive side of the x-axis. So it's going to start somewhere down here and end up somewhere up here. So now once we have that, we want to look at the multiplicity. So for our x equals 0, x minus 6, and x plus 4, all of our exponents are 1. So we could put a 1 right here, right? So what that means is at each of these points, our function is going to cross the 0. So now we have all the information we need to draw it. So we know that we're going to start down here. And as we approach negative 4, we're going to cross because of the odd multiplicity. And then we're going to go back down to this 0 and then cross there because of the odd multiplicity. And then go back up to this 6 and cross the x-axis there. And then end up on the positive side. So this is what roughly our function is going to look like. Now, granted, we don't know how far or tall these humps are going to end up. But for our purposes in pre-calculus, we don't need to know that. You can determine that once you start doing calculus. But as long as you have the rough sketch and you have the end behavior and the zeros all good, then you should be okay. So let's take a look at another example. So let's say we had the function g of x equals negative x minus 1 quantity squared times x plus 2. So in this example, our function is already factored. So right away, we can determine our zeros. So our 0 here is going to be the opposite of negative 1, which is positive 1, and the opposite of positive 2, which is negative 2. So if I draw our graph again, so we have our graph. We're going to have at 1 and negative 2, we're going to have zeros there. And now to determine the degree of our factored polynomial, what we do is we add up the exponents. So here there's a 2, and then here there's a 1. So 2 plus 1 is 3. So we know that this is going to be a cubic. And because there's a negative sign in front of here, there's going to be a negative cubic function. So to determine our end behavior, we go back to reference this. So for negative cubics, our function is going to start up top, but then end down low. So if we go down here, we know that we're going to start somewhere up here, and we're going to end somewhere down here. So now we want to determine what happens in the middle, and that's up to multiplicity. So for our x equals 1, 0, so for this term right here, we notice we have even multiplicity because the exponent is 2. So our function is just going to touch at that point. So I'm just going to label touch. But at x equals negative 2, that factor has odd multiplicity because the exponent is 1. So here we're going to cross. So now if we go ahead and draw our function, we know we're starting up here. So we're starting up here, and then we're going down to x equals negative 2, where we're going to cross the x-axis, right? So we cross it, and then we want to sort of go back up to our other 0, and then we know that we're just going to be touching at that point. So we're just going to touch and then go back down to our other end. And this is what our function will roughly look like, right? So let's go on to the next example. So our next example, I want you guys to try it on your own. So the function is h of x equals x minus 2 quantity squared times x plus 1 times x plus 4. So again, so go ahead and try this one on your own and come back when you're ready to see the solution. All right, so hopefully you've given this a shot and you are looking back to see the solution. So in this problem, it's already factored, so we can determine our zeros right away. So we have a -2 here, so we're going to have a 0 at +2. +1 here, we're going to have a -1. And +4, we're going to have -4. So drawing our graph here, we know that we're going to have -4, -1, and +2. And we're going to have zeros at all those points. And then we want to determine the degree of our function. So in this case, again, we just add up all the exponents. So there's a 2 here, and then these two will have an imaginary 1 because they're to the first power. So 2 plus 1 will be 3 plus 1 will be 4. So this is going to be a 4th degree. And because there's no negative sign in front of the polynomial that makes everything negative, it's going to be positive. So it's a 4th degree positive, which means we're going to stay on the positive side of the x-axis and not leave. So we're going to start on the positive side of the x-axis and we're going to end on the positive side of the x-axis. Remember that sort of U pattern. So now we want to determine what happens in the middle. So we know that at x equals -4 and x equals -1, our factors have odd multiplicity. So this factor right here and this factor right here, we have odd multiplicity. So we know that those points we're going to cross. So here we're going to cross. At x equals 2, we have even multiplicity because that factor is squared. So we know that this is going to be a touch. So drawing our function, we know we're starting up here. And as we approach -4, we're going to cross. And then we want to come back up to -1 because we know that that's going to be 0 and then cross there as well. And then going up to +2, we know that that's going to be a touch. So we're just going to touch the x-axis and then go up and end where we're supposed to end. So this is roughly what our function looks like. And those are the basic steps to drawing polynomials. So the first thing you want to do is determine your zeros, factor in determining your zeros, and based on your factors, you want to determine the end behavior from your degree. And then based on your factors, you want to determine the multiplicity at each zero, so determine whether you're crossing or touching. And then you can just draw your function. As long as you're following the end behavior and doing what you're supposed to do at the zeros, then you should end up with the correct function. So that's how to draw polynomial functions, and we're done.